Thank you to everyone. I would like to say, first off, thank you for the honor to be able to present at the second International Seminar on Big Data. My name is Gordon Reichert, and I will be speaking on the activities of the Joint Task Team on Earth Observation. I am one of the three co-chairs of this particular Joint Task Team. Excuse me. The new task team, or the Joint Task Team that I refer to, was created about 1 year ago with a meeting of the United Nations Committee of Experts on Food Security, Agriculture, and Rural Stats. The creation of a joint task team on the use of Earth observation for agricultural statistics and land cover mapping between UNCAG and UNGWG on big data was approved. I've listed here a number of the members of the Joint Task Team: the Asian Development Bank, Colombia, Data for Now, Egypt, FAO, the German Space Agency, Indonesia, Mexico, Senegal, Statistics Canada, Statistics Poland, USDA NAS, UNSD, Queensland University of Technology in Australia, and the World Bank. The mandate of the Joint Task Team was touched on by Ronald in his presentation, so I'm not going to discuss that any further. I'll go on to focus on the Joint Task Team, whereby we are to identify reliable and accurate statistical methods for estimating data of interest. As well, we suggest approaches for collecting and representing training and validation data of sufficient quality, and I'll touch on some of these examples towards the end of the presentation as well. Research, develop, and implement assessment methods for the proposed models, including measures of accuracy and goodness of fit. Establish strategies for reuse and adapt algorithms across topics, and to build implementations for large volumes of data. With that, the task team is responsible for delivering a recommendation for EO data sources, methods, training for producing agricultural statistics, as well as the use of EO data for land cover and land use. We'll speak a bit about the agricultural statistics, and I'll use an example here from FAO, or FAO, whereby the objective is to provide technical hosting support on the UNGP to FAO in collaboration on a research project with members of the EO task team. This complements the analytical work with the development of best practices or methodology and specific training on EO pre-processing and the actual analysis. The methodology that is implemented is the use of optical data from Sentinel-2, which is optical, and radar data from Sentinel-1, as well as in situ measurements. There are three countries that this is being applied to: one, Senegal, Uganda, and Afghanistan, whereby the use of spectral and phenological features or crop development is extracted from vegetation index fitted models and then is applied transferability of these models. As well, land cover and land use statistics. The new standard for the land cover classification has been developed, which is in essentially the de facto ISO standard. This has been developed and used for the land cover definition under the United Nations System of Environmental Economic Accounts. And there are future collaborations with FAO as well, whereby the development of a national land cover mapping tool for the production of annual land cover mapping. And this is to support the monitoring of land cover, the production of national land cover stats, and it's a pilot project in Lesotho using Google Earth Engine. And as well, the final tool may also be deployed on Digital Earth Africa. The development of the global land cover product is in support of the SDG monitoring, ensuring standardization and harmonization of national and subnational figures. However, there still remains some work to be done because the adequate accuracy greater than 90. Again, I'll touch on this with an example towards the end of the presentation. Although this is dated, about 4 years of age, I wanted to emphasize that the task team also produced a handbook on Earth observation for official statistics. I've included the link, and I encourage anyone to access that handbook and go through it. It's a very comprehensive handbook. It contains a brief introduction on the use of EO for official statistics, types of sources available, methodologies for producing statistics from this type of data, and quality indicators for spatial data. As well, it summarizes some of the pilot projects produced by members of the task team, and I've listed a few of them there with the associated countries that were conducting the research on the pilot projects. In addition to the 4 pilot projects, there are also 5 case studies. The first one being an evaluation and implementation of various machine learning techniques for analysis of EO data for the crop classification. And that was conducted under the Department of Science, Information Technology and Innovation in Australia, as well as the Queensland University of Technology in Australia. And QUT, I'll be mentioning a little bit more when I just touch on the training component within the joint task team. Case studies 2 and 3 resulted in 2 publications whereby there was the implementation of EO data, analysis for the estimation of crop yield, and the last 2 cases where a description of 2 fully operational methods for the analysis of EO data to derive official statistics. And these last 2 have been developed by the National Statistics Office in Canada, as well as the Department of Science, Information Technology and Innovation in Australia. So the point here is that we want to show you that there is a lot of research going on, and there's also a number of operational methods that have been put in play that you could read about and transfer that knowledge to your own projects. The methodology, collaboration with FAO and UNGP, whereby they are working on building in-country capacity. And 2 examples here are Senegal and Uganda. The operational use of EO data for the production of official crop statistics, employing established methods and tools. The methodology that has been used to date is the Sen2Agri toolbox, which was developed by the European Space Agency. And this one was a choice made because it allows the semi-automatic EO data pre-processing and provides a friendly user graphic interface whereby you can classify the EO data and have your crop type maps produced. These crop type maps overcome such barriers by deploying the Sen2Agri toolbox on the UNGP on one end, and then you can use or develop your own Lambda scripts on the other end to automatize further deployment of the Sen2Agri toolbox for other projects. In April of last year, in 2020, the design of the EOStat solution was finalized, and a technical document was also produced and is available. Training, I'm not going to go into this in too much detail. Ralph Mecker is going to be talking about training further. I would like to highlight the fact that the task team was involved in the training aspect, and this was led by Dr. Kerry Mengerson from the Australia's Queensland University of Technology, as well as Dr. De Simone from FAO. To date, the team has developed a 3-stage curriculum, which is meant to lead students from the introductory level of remote sensing to advanced courses with up-to-date data and training sources. The curriculum has been created with the overall goal to teach the fundamentals of using satellite imagery and provide programming skills with relevant use cases for its users. Almost a year ago, September of 2020, I was given the honor to moderate the 6th International Conference on Big Data for Official Statistics, and this was on behalf of the Joint Task Team. Session 8 was use of data for agricultural, environmental, and ocean statistics. There were 7 presentations, and I've listed them here, not going to go into any great detail, but I would like to draw your attention to the link at the bottom of the slide. Please go to that link, and you will be able to hear the entire presentation of each one of these. I encourage you to listen to the ones that you're particularly interested in, or all of them to broaden your perspective of how to use EO data for ag, environmental, and ocean statistics. There are ongoing deliverables. Within the Joint Task Team, there is a research sub-task team, which is co-led by Canada and Colombia. The purpose of this is to collect a list of user cases to be onboarded as part of the UN Global Platform and to be used by Earth observation professionals who have a common goal of using EO for official stats. The research agenda aims to engage experts who use various methods of remote sensing estimations and classifications as part of an official statistical process. And there will be a deliverable in March of 2022 to the UN Statistical Commission. As well, the World Bank has added to the toolbox of methods for agricultural statistics under the 50 by 2030 initiative, and they're focusing on Malawi in that example. As well, there's training, and the training sub-task team I touched on, and I'll just leave it at that. Ralph will go into this further. I mentioned some examples. Here is one from Lesotho, and this one is deliverables from FAO on land cover, whereby the land cover source code was developed in Google Earth Engine, and then a national land cover map was produced in 2021 with an overall accuracy of 89%. And I had mentioned earlier that the 90% was that elusive objective. Well, I think FAO has done very well up to this point, and they will continue to refine that methodology to increase that accuracy. So the next steps, obviously, is the development of EOStat Land Macro Web app with the graphical user interface, as well as produce a national land cover map time series from 2016 to 2022 to observe the changing of land cover characteristics. And then they wish to apply those methods to other countries. Another example is from Senegal, where they have deployed the Sen2Agri on AWS under the UN Global Platform. They have also delivered 5 training workshops, 3 on EO and Sen2Agri and 2 on field surveys. They've also developed a national crop map and crop area indicator statistics. In Senegal, the country, the land cover classification indicated there on the right-hand side of the screen. They've developed an ad hoc survey protocol, and they've also carried out a pilot survey in Miroro. And the example is shown there to the right of the screen. They've also obtained sponsorship from Geo for AWS to ensure computing and storage for next seasonal iteration. I've touched on a number of aspects of the Joint Task Team. I've shown you some examples from different team members. I couldn't show you all the examples from the different members from around the world, but I would like to extend this international invitation to you. The Joint Task Team would like to extend an invitation to anyone interested in participating in this work. So would you please contact any one of the 3 members listed below, and we'd be happy to share the information with you and welcome you aboard. Thank you.